We are doing 2.1a, day 2 today. So it's a continuation from yesterday's. All right, we're going to find the equation of the tangent line. When you see this phrase, equation of the tangent line, that just means find the derivative. And you only have two options when you're asked to find the derivative. You use the alternative version or the limit definition version. Those are the only two. So if you see this phrase, before you do anything, use one of these two options. Okay, so since we're in chapter 2, we're going to use this option right here. Okay, so we are going to find the equation of the tangent line. And we got 3 examples here. All right, so we want the equation of the tangent line of f of x equals x squared minus 1 at that point. So if I'm looking at a graph, I know the parabola has a vertex down at -1. And x equals 1 is right here. There's my tangent line. So I want the equation of this tangent line. Well, if I'm going to write the equation of a tangent line, I need a slope and I need a point. Well, my point is x is 1, and if I plug 1 in here, I get 0. So there's my point. My slope is going to be the derivative of this curve. So let's do that derivative now. I'm going to have the limit as delta x approaches 0. Remember, I take out that x, and I put in x plus delta x, square it, minus 1, minus the function itself, all over delta x. Okay, now I'm going to clean that up a bit. So I'm going to have to FOIL and I'm going to have to distribute. And if I did minus 1, and if I distribute, okay, if I did it right, a bunch of stuff is going to cancel here. This x squared is going to cancel with that x squared. That 1 is going to cancel with that 1. And if I put 0 in for delta x, that's a problem. But if you notice the 2 pieces left over in the numerator, I could factor out a delta x. So if I factor out that delta x, that leaves me with a 2x plus delta x all over delta x. Well, that means that cancels then. So that's good. Now I can plug in 0 for delta x, leaving me with 2x. All right, so that means that my slope anywhere along the curve is 2x. But I want it specifically at 1. So now I have the slope of the curve, which doubles as the slope of the tangent line. I have the point from the tangent line. Now I can write slope-intercept form. So y minus 0 is equal to 2 times x minus 1. Number 2. All right, so same thing. I have this parabola. I want to know the equation of the tangent line at 2. So we need a point and we need a slope. All right, so let's do our point first. 4 plus 2 is 6. 6 minus 3 is 3. So there's my point. Now let's find my slope, which is really the derivative. Now I have to subtract off that function itself. All right, so I'm going to FOIL and distribute. All right, again, if we did it right, things are going to cancel here. So x squared goes with this x squared. Positive x minus x, negative 3, positive 3. Well, 0 in the bottom is bad, but the good news is everything left in the top should have a delta x in it. So I can take out a delta x. Now remember, I'm taking a delta x out of a delta x. So remember, that's still going to be a plus 1. Okay, that cancels. So now we're in good shape. If I put 0 in for delta x, well, that leaves me then with just 2x plus 1. Okay, so that means my slope is 2x plus 1. But now I want it at x equals 2. So if I put 2 in here, I get a slope of 5. So there's my slope. There's my point. So my equation of my tangent line, fit it down here, is going to be y minus 3 is equal to 5 times x minus 2. One more, number 3, and it's kind of a biggie here. All right, so let's kind of break this down. Equation of the tangent line. That automatically means I need the derivative of this function. Parallel means same slopes. So the same slope, whatever you get for the derivative, has to be the same as the slope of this line. Okay, so we need a derivative, we need a slope of the line, and then we're going to set them equal to each other because of this word parallel. Great. Let's get that in the right form. Okay, so my slope is 5, which means my derivative also is going to have to be 5. Okay, so let's take the derivative of this first. Okay, hopefully still rolling there. Subtract off that function itself. All over delta x. All right, we get that kind of nasty step where we have to FOIL and distribute everything. All right, what cancels here? X squared, x, x, 2. Again, if you did it right, you should have only delta x things in the top. So I'm going to take out a delta x, leaving me with 2x plus delta x plus 1. That cancels. If I put 0 in for delta x, that leaves me with 2x plus 1. Okay, this is the derivative, which is also the slope of the tangent line. But I know the slope of the tangent line has to be the same as the slope of that line. So really, those two have to be equal. All right, so if those have to be equal, let's just set them equal. All right, so if I go through and solve that. All right, I want the equation of the tangent line. So to write the equation of a tangent line, you need 2 things. I need the slope, which is 5, and I need a point. So my point is 2, and then we need f of 2. So my point is really 2, and if I take 2 and plug it back into this original problem here, the original function, it's going to be 2 squared plus 2 plus 2. So I have 8. So now I have a point. Now I have a slope. And there's my equation of the tangent line. Problem 3 is a much bigger problem than 1 and 2, so take some time, pause it, rewind it, go back and look at this problem to make sure you understand. And as always, just contact Mrs. Cook or I if you have questions, and we'll be rolling into 2.2 in a couple days. All right, bye guys.